Welcome to third grade math tools. In this math workshop, we will take a deep dive into what math tools, the manipulatives, and the representations that we should use with our young mathematicians to impact their understanding of core mathematical concepts. We will explore why we should provide math tools for our students, what tools to provide, how, and when. Whether you are an educator new to teaching third grade, a homeschool parent teaching your young mathematician, or an experienced third grade teacher, our hope is that this math workshop will provide support and guidance for you as you teach your children mathematics. These are the 5 domain areas for mathematics for third grade: operations and algebraic thinking, number and operations in base 10, number and operations in fractions, measurement and data, and geometry. Let's talk about why we should provide math tools for our students. We agree with this quote from Paul Halmas: "The only way to learn mathematics is to do mathematics." We believe that providing math tools for students to use in math class offers a wide range of benefits, transforming abstract mathematical concepts into concrete, understandable experiences. Many math concepts like multiplication and place value and algebraic equations are inherently abstract. Math tools provide a tangible way for students to see and touch these concepts, making them more concrete and easier to grasp and remember. Providing hands-on experiences helps bridge the gap between abstract mathematical ideas and real-world scenarios. Math can sometimes feel dry and intimidating. Manipulatives introduce an element of play, exploration, and activity, making math lessons more engaging and fun. And increased engagement often leads to a more positive attitude towards math, fostering a lifelong love of learning and reducing math anxiety. Not all students learn in the same way. Manipulatives cater to kinesthetic or hands-on and visual learners, providing multiple pathways to understanding. In grade 3, instructional time should focus on these core areas: developing understanding of multiplication and division, strategies for multiplication and division within 100, understanding of fractions, especially unit fractions. It's 1/2, 1/3, 1/4, so on. Understanding the structure of rectangular arrays in an area, and describing and analyzing two-dimensional shapes. In third grade, there are many multiplication and division standards. Here are just a few to get us to think about while we begin to consider which math tools will support our students' understanding of these concepts. Interpret products of whole numbers. For example, interpret 5 times 7 as the total number of objects in 5 groups of 7 objects each. We see a picture of a similar problem with the inch tiles on the screen. 4 rows of 5. 4 times 5 equals 20. Understand division as an unknown factor problem. For example, find 32 divided by 8 by finding the number that makes 32 when multiplied by 8. 8 times 4 is 32. So 32 divided by 8 is 4. Fluently multiply and divide within 100 using strategies such as a relationship between multiplication and division, knowing that 8 times 5 is 40. Because I know that 40 divided by 5 is 8. Or those properties of operations. Do you remember those? Distributive property, associative property, commutative property. It's not so important in third grade that students can name the properties, but that they understand the underlying concepts of what's going on in the properties. And by the end of third grade, know from memory all products of 2 one-digit numbers. So that would be going up to 9 times 9. Inch tiles are going to be a math tool that is going to give your third graders a lot of bang for their buck with these multiplication and division standards. Here are just some of the ways inch tiles can be used to support your students' mathematical thinking. Students can use inch tiles to cover rectangles, understanding that the area can be found by multiplying the side lengths. Length times width equals area. They can also decompose rectangles into smaller rectangles and add the areas of the smaller rectangles to find the total area. That's the distributive property. Students can use inch tiles to create arrays, like we see on the screen examples, which can visually represent multiplication problems and connect them to area, as well as representing division problems. Students can use inch tiles to visually demonstrate the distributive property in the context of finding the area of rectangles. Here's an example of how students could use the distributive property to help them with their multiplication problems. Let's say that I have forgotten 7 times 7 equals 49. Well, if I know the underlying concept of the distributive property, I know I can decompose one of those sevens or break apart one of those sevens into a 3 and a 4. And if I can recall, well, let's see, 3 times 7 is 21, and 4 times 7 is 28. I can combine the 21 and the 28, which is 49, and that's my 7 times 7. So that's an example of the distributive property and understanding how it works so that we can use strategies to solve problems. In third grade, number lines can be used to visually represent numbers, fractions, and operations like addition, subtraction, multiplication, and division. They can also help students understand equivalency and comparing fractions and solving word problems involving time intervals. Number lines can be used effectively to meet these third grade standards. Fluently add and subtract within 1,000 using strategies and algorithms based on place value, those properties of operations, and or the relationship between addition and subtraction. So for example, that first open number line you see on the top of our examples on the screen, for that problem, I was asked to think about 37 plus something else equals 85. What is it? I used an open number line to find my answer. I decided to add 40 to 37, and that got me to 77. Then I thought, ooh, 80's right around the corner. That's a nice round number. So I added 3 to 77 to get me to 80. Then that was very easy for me to think, oh, now I got to get to 85. That's just plus 5 more. Where's my answer? My answer's in the hops. Plus 40, plus 3, plus 5. 40 plus 3 plus 5 is 48. So now I know 37 plus 48 equals 85. That's an example of how an open number line can help me solve a problem with addition. I can do the same thing with subtraction using a number line. The next example we have in the middle of the slide, we see multiple number lines. We see 3. And they're helping us to think about equivalent fractions. So we can see that a half is the same mark, same distance from 0 to 1 as 2/4 and as 3/6. So we're visually seeing that equivalency. But on the bottom, we're seeing an example of using a number line to help us with time interval problems. So some of those other standards I wanted to share with you where number lines will support our third graders. Here's one. Understand two fractions as equivalent or equal if they have the same size or the same point on a number line. Here's another one. Tell and write time to the nearest minute and measure time intervals in minutes. Solve word problems involving addition and subtraction of time intervals in minutes by using a number line diagram. Grid paper. Grid paper can be a valuable tool in third grade, particularly for supporting visual representations and understanding of key concepts like area, arrays, place value. It helps students visualize and manipulate numbers, making abstract concepts, more concrete. Here's how grid paper can be used. Finding area. Students can use grid paper to draw rectangles or other shapes and count the square units within to calculate area. Connecting area to multiplication. By visualizing a rectangle as a rectangular array of squares, students can connect area calculations to multiplication. Area equals length times width, just like we were talking about with inch tiles. Exploring rectangles with a given perimeter. Students can use grid paper to explore different rectangles that have the same perimeter, helping them understand the relationship between area, perimeter, and shape. Representing multiplication. Grid paper can be used to create arrays, where each row and column represents a factor in a multiplication problem. Understanding multiplication strategies. Students can use grids to visualize and apply strategies like that distributive property we just talked about by breaking down a number before multiplying. We can show that visually on the grid. Dividing with grid paper. Grid paper can be used to model multiplication and division problems where students can visually represent the division process by grouping objects, squares on the grid, into equal sets. Visualizing numbers. Grid paper can help students visualize the place value of digits, particularly when representing multi-digit numbers. Now let's look at some of the fraction models we want to provide for our students to help them truly understand fractions. We already talked about the use of number lines to support understanding of equivalent fractions, and also it helps with comparing fractions. But let's listen to this third grade standard. Understand a fraction, 1 over b, as the quantity formed by one part when a whole is partitioned into b parts. Understand a fraction ab as the quantity formed by a parts of size 1 over b. Here's another third grade fraction standard. Recognize and generate simple equivalent fractions. For example, 1/2 is equivalent to 2/4. 4/6 is equivalent to 2/3. Explain why the fractions are equivalent by using a visual fraction model. Well, fraction strips are produced by many educational companies, and they typically come with the fraction name pre-printed on each section. The benefit of using fraction strips to support students' understanding of the area or region model is that the student can line up and compare the size of the fractional pieces. For example, they can visually see that 1/3 is larger than 1/4. In fact, they could even line up two 1/6 pieces and see that they cover the same area as a 1/3 piece. Fractions can seem so abstract, but being able to put your hands on them and touch them and see them and compare their size helps you to find equivalency and helps fractions come alive. Our favorite fraction strips are produced by Marilyn Burns. The Marilyn Burns fraction kit contains magnetic strips of fractions. They're very long-lasting, sturdy. If you have something magnetic in your classroom, like sometimes whiteboards or the side of a file cabinet, they don't have to be displayed in that way. Students can also use them with playing games and solving problems and thinking about fractions, but that's one way they can be used. But also in the Marilyn Burns fraction kit, you're going to get a class set of multicolored paper strips that match The colors that you see on the screen, those are actually the magnets that go in the set. And there's enough for every student in your class. And what students are going to do is they're going to, through a lesson that you lead, they're going to cut the fraction strips to match the example you see on the screen and label the strips. And not only that, every student will have a long baggie that's included in the fraction kit to keep their fraction pieces in. Now, I'm going to be honest with you. This activity does take time, but the learning and the understanding that comes from students actually cutting the fractional pieces and writing and labeling the name of that fractional amount is invaluable. And a little tip for you, have students write their initials on the back of each fraction piece, because occasionally the fraction pieces might end up on the floor, and then it's easy to see, oh, this belongs to so-and-so. The kit also comes with a fraction booklet that has games and lessons, and it also includes fractional dice that students use to play some of the fraction games. It's hands-on, the best investment you can make for third grade for your fraction standards. You can purchase this kit at the Heinemann website. Our second favorite fraction tool to use with third graders are Cuisenaire rods, because they can be used to represent that area region model, but they can also be used to represent that measurement model of fractions. Now, these wooden rods are strategically and purposefully created to represent fractional relationships. So, for example, I could say to my class, let's say that the orange rod, that's the one on the far right of the screen, equals 1 whole. What would we call the blue rod next to it? And through exploration, students would figure out it's 9/10, and that the brown one next to that is 8/10, and all the way down, and that little white cube or white rod, 10 of those equal the orange rod. Double checking. Thought that I misspoke, but I did not. The powerfulness in having your students use this tool is that the fractional parts are not labeled. So students have the gift of discovery and exploration to figure out what to call each fraction piece. And not only that, we can really push students' thinking and being flexible, which is such a great habit of mine that we want from our mathematicians. And I could spice it up and say, now, no longer for right now, the orange one's not a whole anymore. Let's say the red one equals 1 whole. What would we call the white rod? It's 1/2, because 2 white rods equal the red rod. Or let's keep the red rod as a whole. What would we call the purple rod? Well, that would be 2, because 2 reds equal a purple. I know it's hard to see this as you're just looking at the screen, but your students would have their hands on these tools and exploring. All right, let's continue on. Next up, for fraction tools, we love pattern blocks. So these geometric shapes can be used with fraction exploration, as well as supporting the area region model. For example, I could say to students, and again, they're going to have their hands on these. I could say, let's pretend the yellow hexagon equals 1 whole. How much does the red trapezoid equal? And so students would be exploring and probably turning and rotating the red trapezoid, and they would discover that 2 red trapezoids fit perfectly on top of the yellow hexagon. So 1 red trapezoid is 1/2. I love pattern blocks, just like I love Cuisenaire rods, because they're not pre-labeled or pre-printed on. So students, again, have the gift of discovery But of course, through our intentional questioning and lesson, that we're asking these rich questions. So I might even spice it up and say, okay, now let's say that the red trapezoid equals one whole. I wonder how much a green triangle represents. And so again, students would have their hands on the tool and figuring out that three green triangles fit perfectly on the red trapezoid. So a green triangle is 1/3 of the red trapezoid. If you are blessed to have an interactive whiteboard in your classroom, there is a website, the Math Learning Center, that has a free interactive pattern block visual representation, which is a great way for while your class is doing their exploring with the questions that you're posing to them, that students can come up and visually model how they're figuring out the answers. All right. Next up, we have measuring cups and analog clocks. And they can be used also with fractions, of course. Real life examples. Maybe we have students explore, well, how many 1/8 teaspoons make up 1/4 teaspoon? And of course, students would see that 2 1/8 make up a fourth. Or we might say with the analog clock, how many 15 minutes are there in an hour? And of course, we'd want students to figure out there's 4 15-minute sections in an hour, or how many 15-minute sections are in 3 hours, or how many 5-minute sections are in 60 minutes, and relating that back to fractions. It's a great visual model. Here are the top 5 comments. I put on a bonus one for you that teachers say, and this is especially upper grade teachers, as to why they don't use math tools. Number 1, we don't have time. Number 2, I don't know how and why to use them. And probably the most popular is number 3, my students can't handle it. Number 4, I didn't learn that way, so why should my students? Hopefully, this math workshop helped you with the second comment, providing rationale for the how and the why. And we respect that you are the professional in the classroom and that it's your decision on how to provide the best instruction possible for your students. But we do want you to consider for comment number 1, we don't have time, that your students' time spent truly understanding math concepts through the use of math tools leads to deeper understanding. It leads to memory retention of the math concepts because they really understood the math idea. If students don't understand why they're performing math steps or following certain procedures or algorithms, it's very likely they will forget what they were doing and how they were doing it, meaning they're going to make a lot of mistakes, and meaning next year they're going to have to relearn what they learned the previous year because they weren't internalizing what they learned. So our gentle response to the first comment, we don't have time, is how can you not take the time for real learning and understanding? We encourage you to watch this math workshop again and share it with a colleague. We know that teaching is so much easier and better when we have the support of working alongside colleagues who are committed to collaboration, sharing, and being along this educational journey with us. For the third comment, my students can't handle it, we're going to offer you some tips for successful implementation on the next slide. For the fourth comment, I didn't learn that way, why should my students? That's probably true for a lot of teachers. Our response is that research shows that most learners, that's adults and children, learn best through tactile, hands-on, and visual experiences, especially in mathematics where the concepts tend to be very abstract. So for my personal opinion, I didn't learn using math tools. I am so grateful now that there are math tools because my own journey as a math learner has exploded due to the tools. And the fifth one we haven't talked about yet, and this one we hear a lot too. They can't use the math tools on the end of the year test, so why should we let them use it during the year? Well, I can understand why educators say that. It's true that most end of year tests, I think they have different rules and different guidelines, and different students have different accommodations, but mostly math tools are not going to be part of the end of the year test. But we have to remember that if our students are using the math tools throughout the year, students have deeply learned all about that math concept and they've internalized it. So when it comes time to take an assessment or an end of year test, most likely, this is what we've seen, students are going to be very successful because they've internalized that learning and now they really own it and they know it. So they can produce on a test. Here are the tips for successful implementation of math tools from teachers. Number one, give students explore time every time. And we're just talking maybe 2 minutes. Set a timer and tell your students, all right, we're about to use this object as a math tool. But first, here's your 2 minutes to explore. It's your time to check out this tool, feel it, look at it, turn it over, explore, see what it does. And then when the 2 minutes is up, you say, all right, we're going to use this tool now as a math tool. Now it's focus time. Number two, set clear expectations. Before ever passing out a math tool, share this is how it can and cannot be used. For example, with geoboards and rubber bands, I would tell my class, I am not going to see rubber bands flying across the room. That is not how these are going to be used. If they are used that way, you will lose the math tool, the privilege of using the math tool that day. And honestly, students don't want to lose that opportunity. Then they just have to sit in their seat and watch their friends, their classmates using the tool. They don't want that. So if we just set clear expectations in the beginning, this is what we're not going to do. Most likely, most students are going to keep the privilege of using the tool. Number three, modeling usage, showing students this is how we're going to use the tool. Number four, considering storage. So consider those options that work best for your budget, your space, your students, and yourself. Do you want to provide math toolkits or toolboxes for each student where the items inside rotate over time and students have choice? We've seen this very successfully implemented across the country. And you can have a classroom helper job that student restocks the math toolkits regularly. Students really enjoy having a choice of what tool to use to help them solve a problem or to help them think about something. Or would it be better in your space and with your budget to have a math tools area in your classroom where the math tools are maybe in plastic bins? Possibly consider having table group baggies or individual student amounts in baggies, whatever works best for the activity and is going to be a quick passing out and a quick collection and no loss of instructional time. Our hope for you is that you found this third grade math tools, math workshop very supportive. If you did, I invite you to join our third grade math workshop community. When you join this private community of other third grade educators, you will gain access to other math workshops similar to this one that dive deeper into understanding the standards, the models, the tools that will support your third graders in their journey of being mathematicians throughout the year. Monthly, you will receive engaging hands-on activities, lessons, games, number sense math routines, and so much more to support those third grade math standards. You can find out more information on how to register to join our third grade math workshop community on our website, themathworkshop.net. Go to the resources page and then find your grade level, grade 3, and you'll find out more information. We thank you for your time and we hope you have a great school year.